Let's continue talking about slope. Slope is given by the variable m. We call slope m. And slope we know to be the rise over the run of a graph. Rise, that's the up and down part. That's the y variable, the change in the y, over the run, which is the change in the x variable. Okay, so let's have a look at the first line, the blue line on the screen in your notebook, this line that I've labeled number 1. And let's look at counting the rise and the run of that line. Now, from looking at it, we know that the slope will be negative, right? The line is going down. What we do is we find 2 points that the line is for sure going through, right where the grid crosses. It's easiest. And we want to count the rise, the up and down change there, which is 4, and the run, how much it's moved side to side, which is 1 in this case, 1 grid square. And so we know the slope of the blue line, m, is equal to the rise. It looks like it went down 4, so we have a negative 4, and it went to the right 1. Okay, so the change from the first blue point, the higher one, was 4 down and 1 over to the new blue point. So we say the slope is a negative 4 over 1. Let's look at the black line next. This line labeled number 2. Now let's find 2 points where it goes through. It looks like it goes through all these. So the change here, we have up 1 over 1. The slope here would be rise of positive 1, run of positive 1. So we say the slope is 1 over 1, or just 1. Let's look at the orange line. This is line number 3, this line here. And we find 2 spots that it's going through, here and here. Looks like about right. And let's count the rise. So the rise would go 1, 2. So when I say rise, I don't mean it has to always go up. I just mean the change in the up or down. So we're actually counting downward here. 1, 2, 3, 4, 5, 6, 7. 7 down. So that would be a negative 7. And then how many over? What's the run? 1, 2, 3. 3 to the right. So we say the slope is a rise of negative 7 and a run of 3. Our last line is green. This is line number 4. Sorry, green. And number 4. If we find 2 points that it goes through, let's say here and maybe here. Okay, in this case, let's see how much the rise. 1, 2, negative 2. I went down if I'm starting at this point, and 1, 2, 3, 4, 5, 6, 7, 8. Negative 8 to the left. Now, had you started at the point that was on the left, you would have counted over positive 8, a run of positive 8, and a rise of positive 2. Either way, you will get the same slope. So I counted a rise of negative 2 and a run of negative 8, which 2 negatives will make that positive. And if I divide by 2 or reduce, I would have a positive slope of 1/4. Okay, turn the page. Slope we know is m. We wrote that down already on the previous page. We know that slope is the rise over the run. And so we can use the idea of finding the change in the x's and the change in the y's to come up with this little formula. So it's going to be the second y point minus the first y point. That's the change in the rise, what we were just counting. And the change in the run will be the second x point subtract the first x point. So we see that we don't, using this formula, we don't have to have a picture or a graph of the line. We can find the slope using this formula just with a sentence, like the example below. It says, find the slope of the line that goes through point 3, 4 and 10, 12. So the first thing we need to do is just designate which is point 1 and which is point 2. Okay? Now let's use that formula. Slope is going to equal y squared minus y1, not squared, y2 minus y1 over x2 minus x1. Now the y coordinate from point 2, oops, I scribbled it out, is this one. So we're looking at 12, subtract the y coordinate from point 1 is the 4, divided by x from point 2, the 10, subtract x from the point 1, which is 3. So our slope will be 12 minus 4 is 8 over 10 minus 3, 7. We say this line has a positive slope of 8/7. If we look at the next question, we're asked to find the slope if the -1, 5 and 6, -2 are on the graph of the line. So again, it's giving us 2 points. We will identify one point as point 1, one point as point 2, and use our formula to calculate the slope. Y of point 2 minus y of point 1 divided by x of point 2 minus x of point 1. So the y from the second point is -2. Subtract the y from point 1 is 5, all divided by x from point 2, subtract the x from point 1. And then we have 2 minus 5, -2 minus 5 is -7, divided by 6 minus -1. We know those two negatives make a positive, and we have 6 plus 1, which is 7. And so our slope, if I would do that division, would be -7 divided by +7. We have a slope of -1. And our last example on this page, it says find the slope of the line that goes through blank and blank. I want you to put 2 coordinates in there and find the slope of on your own. Okay, pause it here. Now, together with that calculating slope, we're going to look at the slope-intercept form of a line, because this is another way we can see the slope. Okay, so we're learning kind of 3 ways to find slope. The first way was just looking at rise over run and counting on the graph. The second way was using this little formula, so we didn't have to have a graph. And the third way now is going to be looking at the equation and just identifying which number is the slope. So we have the slope-intercept form of an equation, and it's given like this: y equals mx plus b. Hopefully this rings a bell because you have seen this before. In this equation, we already know that m is the slope. That's the variable we've designated to mean slope. And b, in this case, is the y-intercept. Now, because we've just finished quadratic equations, you'd wonder, or you might ask yourself, why they didn't call that c. Because when we deal with quadratic equations in standard form, we know the y-intercept is a c. But when we're looking at slope-intercept form, we call the y-intercept b. All right, and the x and the y are simply the x and the y from any ordered pair. So if you're told what the x value is and you want to find the y, well, plug x in and solve, and you'll be able to find the y coordinate. Okay, so when we look at these equations below, I'm going to grab my highlighter, it's asking us what is the slope. Okay, well, I know the slope is this fraction, or the number, the coefficient of the x variable. So I can by looking at these equations, identify the slope. So if I'm going to write my answers in, I would have m is equal to 2/3. This is a positive slope. That line will be going upwards. Here, m is equal to -3/7. M here is equal to 1/10. And here m is equal to -4. Now we know slope is often a fraction. So if I wanted to know the rise and the run of this slope, I could put it for -4 over 1. Okay, and you can see which slopes are negative going down, which slopes are positive going up. Turn the page. When we're given a question that is not in slope-intercept form, you need to do that solving of those equations for the variable y before you can identify the slope. We have practiced solving equations, so this shouldn't be too difficult for you. Again, I will write the slope-intercept form at the top so you remember what we are going for, or what are we trying to make it look like. So in this first example, we see 5y. We know that 5 cannot be there. Our slope-intercept form has a 1y as the left side of the equation. So we need to divide by 5. Now, you can write it like this on the right. That would be true. Because I'm looking for two different numbers, what I'm going to do is write each part divided by 5. It's the same thing. 5 over 5 will be 1. That's what we're going for. And now we have 2/5 x plus 10 divided by 5 is 2. We can easily identify our slope now that it's in slope-intercept form. Let's look at the next question. Okay, so here we want this positive 18 to be on the right side. We also want this 9y to be 1y. So first step would be to subtract. We do the addition first, subtraction first. That will be 0. So we have 9y is equal to 3x minus 18. And then we need to divide each term by 9. And y is going to equal 3 over 9 reduces to 1/3. X minus 18 divided by 9 is 2. And there, if we grab my highlighter, we can see the slope of that equation. In this next one, I see it is already 1y. We need to move the 7x to the right and the -1 to the right. You could do that in just one step. I'm going to take 2 steps so I can show all my work. So first we move the constant term. We add 1 to both sides. Secondly, we're going to subtract all the x's. We want them to be gone too. We have 0 x's now, and y equals. Now we're going to put, just because this standard form here, or this slope-intercept form has the x's before the b's, right? We're going to write -7x plus 1. And again, we can see the slope is this coefficient on x. Our last example, we want to take the x to the other side. 3y is equal to x. And then we're going to divide by 3. And our results is, now x over 3 is the same thing as 1 over 3, right? And there's no b. I'm going to write in the plus 0. And here's my slope. So now if I was asked to give the slope, I would be able to identify them in the green writing as shown here. One last idea here. If these black lines have a slope of -4/5, and in this first example the orange is parallel to the black, we can see that the orange would have exactly the same slope. Parallel lines have the same slope. So the question here, what is the slope of a line parallel to this equation? Well, it would be exactly the same. Perpendicular lines, or lines that are 90 degrees, have a negative reciprocal. So if I would write the slope of this orange line, I would change the sign and flip the fraction, and that would be the new slope. So for example, in this equation here, a slope perpendicular to this one would be +3/2. And here's your assignment. Good luck.